Hello there, and welcome to episode 12 of How to Program in C++. Today we're going to do some more on iteration structures. This time around we're going with the for loop, which is very similar to the while loop, except it has slightly different syntax to it. Where a for loop is generally used to loop around until a condition has changed, such as you've specifically said exit this loop or whatever. A for loop is more like do this thing a certain number of times. Generally, for loops will have a specific amount of times that they are to iterate or loop round, which is kind of predetermined by what you tell it to do. So let's get started. First things first, you need the keyword for, and then you open brackets. Now this is where the syntax is going to get very strange for those of you that have been following along the tutorials, because we've not actually done anything like this before, or any syntax that is just like this. I'll explain as I go along though, so it should be fairly easy. The first thing you want to put in these brackets is the initialization, and that would basically be you're initializing a variable to be your counter for your loop. So in this case I'm going to make int C, and that's going to stand for counter, and then I'm going to set this to 0. Now this is exactly the same as you would create any other variable, as we have been doing all the way up until now. Now here's where it gets a bit weird. You put a semicolon directly after this statement, but still within these brackets. And now you write your condition in. Now the condition is written exactly as you would for a while loop. So we're going to say if C is less than 10, then execute this statement. Then you put it in another semicolon, and finally there is one more thing that we've got to give the for loop, and that is an increase, which is basically just a statement. Most of the time in this space you will add or take away a value from this counter variable that you have created. So we're going to do C++, because that will increment C by 1. And then we're going to make a block, and we're going to just put in a statement. This is a loop. And then I'm going to hit full stop. Gonna add an end line so it's readable, and there we go. Okay, let's run this quickly, see what happens. So, as you can see, it has executed this statement 10 times. Because we have said loop from 0 to, well, basically 9 in this case. A way to make that more obvious is by adding, you can actually use this variable within the for. So I'm just going to output it. This is loop number, and then I'm going to stream in the counter from our for loop. So let's see it in action. There we go. It has gone from loop 0, 1, 2, 3, 4, all the way to 9. So let's break it down a little bit more, or reiterate over what I've just gone over. How this executes is the first time round it will be like, okay, I'm going to set C equal to 0, and then I'm going to check that C is less than 10. If C is less than 10, then I'll execute this statement, and then it goes back and it performs this statement that we gave it in the increase section of the for loop. And then it will go back and check this condition again, and if it comes out true, then it will execute this statement again, and so forth, until this condition comes out as false. Okay, so now that you know the kind of basics behind a for loop, you can do a couple of other things with it too. Now watch out, because if you make a condition that will never become false, it will just keep looping forever. So if I put, say, C is larger than -1, this is eternally going to be true, because C is just going to increase greater and greater and greater, and we're going to have an infinite loop that just keeps going like this. So watch out for that. Don't let that happen, because it will just cause your program to get stuck. So, as I was saying, you can modify this. You can change all three of these things. Let's first go over the increase. You can actually decrease the counter in this area. So let's set C equal to 10. Let's make sure that it's checking if C is larger than 0. And we're actually going to decrement the value this time. And the exact same thing happens except from in the reverse. It will start out at 10 and go all the way down to 1. Because that's how long this condition comes out true for. A couple of other things you can do. You can actually completely remove... you can leave the initialization completely empty. You can also leave the increase empty. So, for example, if I was to make an integer called C and put it outside of here, so we'll make 10 outside here, and then add in this C minus minus at the end of our block, this would be essentially the same thing as what we had before, except from this time we're not using these two attributes of the for loop, which is kind of pointless. It defeats the purpose of using a for. We may as well be using a while loop, but I just want to show that that is something you can do. So let's wipe our for loop back to a kind of more regular state, I guess. Actually I'll set C to 0. I'll check if C is less than 10, and we'll make it C++. Wow, that's kind of weird that came out like that. Anyway, let's build and run, and yes, we're back to here. Now, there's one other thing I'm going to teach you about for loops, and that is you can implement the comma operator that we found out about before. Now, let's do it the right way first, and I'll explain something you can't do. So there is a limitation. You can only initialize one variable in here. So if you're going to initialize multiple using the comma, you've got to create it outside of the for. So we'll make one called C, and we'll make one called D, because why not? And then I'm going to use the comma operator and add in another initialization. So now we have both C being set to 0 and D being set to 0. And as you can see, it still works. You could do as many commas as you want. Does not matter. However, for the most part, you will only be using 1 or 2 counter variables per for loop. Most of the time, only 1. This is kind of an extreme case. Now, you can do the same thing over here with the comma operator. So we could do D minus minus. And that way, well, let's see out D for each loop. D. There we go. That'll work. And end line, semicolon, and run this. And as you can see, it also is taking away 1 from D each time. And by the end, D is minus 9. So I'm going to set 9 equal to 10, and then we're going to add one more thing. We can actually implement both these variables into the condition. Now, you can't put a comma in here because that wouldn't make any sense. You could, however, use the AND operator as we went over before, but in this case, we're just gonna implement C and D into one condition. So let's check if C is not equal to D. So as long as C is not equal to D, it will continue to loop around. Okay, let's go. And as you can see, it goes round until D is equal to C, which would be value 5. However, it does not print that out because by the time they are equal to each other, it just skips over this statement. Now, just to confirm what I was saying earlier, you cannot declare the variable in the initialization section if you're using the comma operator. So in this case, if I was to put in int C equals 0 and then the comma and then int D equals 0, the compiler will get very confused and will bring up an error. But remember, you can declare your variable if you are not using the comma operator. So if we take out all the references to D, then this will still work. So, boom. It works or compiles. In this case, C is immediately equal to 0, so this statement is never executed. Okay, thanks for watching, guys. Sorry this one has been a little bit funky. I am tripping over words a lot because I'm very tired. I apologize for that. Next episode, I will get up bright and early and give you one when I am more fresh and ready to teach. Okay, thanks for watching, guys. See you next time.